So for this example, we are looking at a cumulative frequency polygon. Now the polygon that we have over here, it shows the birth weights of 50 children. Let me just highlight or identify that there's a total of 50 children. Now what we need to do is estimate the number of children born with a birth weight of less than 3.5 kilograms. So we are looking at less than 3.5 kilograms. Now, what we do is we go to our mass axis, so which is the x-axis, and locate 3.5 kilograms, which is just somewhere over there. So that's 3.5 kilograms. And from 3.5, all we do is we just go up to see where does it intersect with our polygon. Okay, that's the point that it intersects with our polygon. And we read across. And just identify whatever that value is at 3.5 kilograms, and that is roughly 22.5, or a cumulative frequency of 22.5. So we can write down, so that point is roughly 22, 22.5. It looks more like 22. So anyway, we can write down that the number of children with less than 3.5 kilograms is approximately 22. Okay, so we'll just highlight that over there and that bit over there. Okay. Then we are also asked to estimate the number of children born with a birth weight of more than 4.2 kilograms. So take note that it's not less, it's more than 4.2. Again, the process is not different. We go up to 4.2 on our mass axis. So 4.2 would be somewhere about there, roughly. Okay, so all we do is we just take a ruler, go up to until it intersects our line, and read across, which is 40. So what that means though is that there are 40 children with less than 4.2 kilograms. But the question is asking for more than 4.2. Therefore, whatever the total was, which is 50, you take the 40 away from the total. So what you do is equal to whatever the total 50, you take away 40, and that gives me 10 children. Let's just highlight this bit over there. Alright, and for the second example, this is where we are given a frequency table, and that's for 24 girls in year 11. And what we need to do is to draw a cumulative frequency polygon and construct a box plot for the data. So there's two parts to this. We need to first draw a polygon and then construct a box plot. Okay, so the first thing that we will do is just to add a cumulative frequency column. Okay, so there's a couple of ways of doing that. You can just add it over here, or I'm just going to make another one, so you can just add a column there. Okay, that will be a CF column. Or you can just make another one. So this is another way of a frequency of a CF table, of a cumulative frequency table, where all we've done is we've added another column, and what this does is this has just identified what the starting and the finishing values are for each interval. So if you look up over here, we started at 155 to less than 160. So that's the 155 to 160, 165, and so forth. So if you notice that the starting value of 155 is what we started with. Now this helps us with the frequency polygon, and as you'll see in a while, in terms of how we plot those points and how we plot against those intervals for these frequencies. So the next thing now is to construct the frequency polygon. Okay, so if we draw the cumulative frequency polygon, that's what we get. So we just get that where, if you notice, the important thing to notice is that because we are starting at 155, so from 0 to, and then from there on the intervals are with a difference of 5 centimeters. So what we need to remember, just gonna list one there. What we need to remember is that we need to indicate on our axis that all of these values, so that squiggly line over there means that there's all of these values between 0 and 155. Okay, so because it starts at a large value, we just show it with that squiggly line. And along our y-axis, which is the cumulative frequency, we just got it at an interval of 2. Now, as I was saying before, so with our first value at 155 at 0, and I said that we'll be looking at it, how it reflects on the graph. So this interval from 155 to 60, so whatever the frequency was for that, which was 2, that is plotted against the end of our interval, which is 160. So the 2 is plotted against the last value of our interval of 160. Then from 160 to 165, our frequency was 8. So the 8 over here is plotted against, or maybe, yes, so that 8 is plotted against 165. And likewise, all the other values, the end value is plotted against the whatever the cumulative frequency was. So if we have a look, our cumulative frequency values are 0, 2, 10, 20, and 24. And if we have a look at our intervals, 160, so 0 was at 155, 160 to 2, 165 to 10, 170 to 20, and 175 to 24. All right, so that's the first part, which is drawing the cumulative frequency polygon. The next part we have to do is to construct a box plot. Now, to construct a box plot, to do this, the things that we need are our 5-figure summary. Okay, so let's calculate our 5-figure summary. So we know what our minimum and maximum is, so let's start with our Q1, Q2, and the Q3 values. Let's find the positions first. Now we do know that to find our Q1 position, Q1 position is given by n plus 1 over 2, and then Q2 position is given by n plus 1, sorry, not over 2, over 4. Q2 is over 2, and then our Q3 position is given by n plus 1 times by 0.75. Now, what I've got over here is just a little bit of information that when your data is a large amount of group data, you can read off your quartiles at 0.25, 0.5, and 0.75. So what that means is that your Q1 position can be read off as 0.25n, so our total was 24, so which means 0.25 times by 24 this gives us 6, so that means our Q1 is at the 6th position. Then Q2 can be, according to that, can be found by 0.5n, which is equal to 0.5 times 24, and that's our 12th position. And similarly, Q3 can be found by 0.75n, which is 0.75 times 24, and that gives us the 18th position. Now, what we do then is that we locate these positions on our polygon. So we locate the 6th position and the 12th position and the 18th position on our polygon on the cumulative frequency column. Okay, and let's see what we get. So if we go up, just going to underline so if we go to our polygon and look for each of these positions, 6, 12, and 18. So let's just identify that over there, and over there, and over there. And we'll have to read across, and read across to our polygon and find out what height does it read down to. And we can see that that gives us our Q1. Along the 12th position gives us our Q2, and along the 18th position gives us our Q3. So I'm just going to underline it according to the color that I have. And the 18th position is our Q3. Okay, so that's all you had to do. But the second part to that was to construct a box plot. So as we can see, we've identified what our Q1, Q2, and Q3 is. Obviously, 155 is our minimum value over here. And 175 is our maximum value. Okay, so let's draw a box plot using the same axis. I'm just going to use the same axis, which means that okay, so we'll just use the same axis. This is 0 with the squiggly line over there. So we have 155, along with that 160, 165, 170, and 175. Let's mark our 5 figures. Okay, so 155 is the minimum value there. This is our Q1, somewhere in the 160 and 165 range, so somewhere over there. So just line it up. Q2, somewhere there. Just a little bit more than 165. Just going to make it more accurate looking. And then Q3 just under 170. And our maximum value at 175. Let's draw a box. Neat box. Okay. And if you can see, this lines up with our Q1, our Q2, and our Q3.